So in today's video, we are going to solve this problem, binary tree zigzag level order traversal. So here we are given a binary tree, and what we need to do is we need to traverse it in a zigzag form. That is, in first level we have to go from left to right, then in second level we have to go from right to left, and then again left to right, and so on and so forth. So let's walk through this first test case. So in first level, we walk through from left to right. So it only have one node anyway. So it doesn't really matter. So it is 3 in first level. And in second level we will walk from right to left. So it will be 20 and 9. And then again from left to right. So 15 and 7. So this is the problem that we are given. So now let's come to the solution. So one thing you will notice here is that we have to traverse in level wise manner. So we will be in this level, level 0, then level 1, and then level 2. So to traverse in a level wise manner, we use breadth first search. So in breadth first search, what we do is whatever option we have. So for example, if we are at 3, we will go to all the options that we have. So we have 9 and 20. At max, we will have two options here because it is a binary tree. But let's say if it wasn't a binary tree, then we might have more options. So 3, 4, 5, 6 nodes can be here. And then we would have gone to 9, 20, and so on and so forth to those other nodes without going without exploring the option from 20, whichever node we encounter from 3. So that is breadth first search. Let's come to the code. So here I have used a queue for breadth first search, and if we are not given anything, so for example, this is example number 3, we are not given anything, so we will return an empty array in that case. Otherwise we will push the option which is given to us, that is root, which is 3, and then this is our answer. And I have declared a boolean variable here which will tell us if we have to go from left to right or not. Then we will check if our queue is empty or not. It shouldn't be empty, and this will give us the number of nodes that are at that level. So here I have pushed root, which is 3, and the size will be 1. So this tells us that at this level where we are currently, there is only one node. So it will be 1. And then this is a vector I've taken. So what I will push in this vector will be this thing, 3, then 20 and 9, basically all the nodes that will be in that particular level. And now I will traverse in that particular level, and here I will take whatever node I am at, and I will pop it out of that queue, and then I will push the value there. So 3 will be pushed there, and then I will check if there is a left from that. So there is 9, so I will push 9, and if there is right, then I will also push 9, 20. And then I will check if I have to go from left to right or not. So in the first level, which is the 0th level, I had to go from left to right. So this will be false because see, notice here it is a false. It has a exclamation mark. So that means not left right. So this will not run, and it will just push 3. This level that I have here, and I pushed 3 into it, and then it will just make it inverted. So if it was true, it will be false, and if it was false, then it will make it true. So let's do a try run on this one. So first we have already seen it will just push 3. The second time it will have 9 and 20 inside the queue. So n will be 2 in that case, and it will again traverse in that level number 1, and so it will take 9, and it will push 9 into that level. So it will be like this, just 9, and then it will check if there is a left. There is no left, it will leave it. There is no right, leave it. and then go back again. So it will go to 20 and then insert 20 also here. And in the queue, it will insert 15 and 7 because they are both there. And then this will be left to right will be false and not left to right will be true. So it will reverse it. So 9 and 20 will be reversed. So it will be like this 20 and 9. And then it will push it into the answer, which should be the case. And it will make it true again. So again, when we will go back, we will again have two nodes at the second level, zeroth, first and second level. And then again, we will do the same thing. We will push 15 and then we will push 7. And that's all it will do. And at the third time, it will just push it because this will be false. And it will come out because there is nothing to push and this statement will be false in that case. So we will return answer. As always, let's also look into the time and space complexity. So for time complexity, because we are traversing on every node, so it will be O of n, or let's say n is the total number of nodes here. And for space complexity, now space complexity will be little different because you see here we will have to traverse, but we are also popping the value on the go. So at max, how much value will we save into our queue? That will be time, space complexity. So if you notice, in this case, we only stored two value at max. So the space complexity will be the maximum width that we have got here. So that will be time and space complexity.